Today I just want to give a sneak peek into the Frame 3D module. I have been developing for a while, and hopefully I can release it soon as a beta version. So I just want to give a demo of what is the new features in the new module. So this is taking StandardSolver into a new level where now you can do 3D analysis, pretty much 3D frame analysis. So if you have used StandardSolver before, it's pretty much same but in 3D. So you can define your sections, but since it's being 3D, you need to enter much more data, kind of moment of inertia in the z, y directions, and kind of polar moment of inertia to consider the torsion effects. Also, there is now an option to include element weights in the analysis. So for that, you need to enter the cross-sectional area and density. So weights can be calculated, and the gravity-induced loads can be applied in the model. So let's see what features we got. So now, compared to other modules like beam analysis, Frame3D, you need to define the nodes in 3D. So let's create maybe a portal frame quickly. So let's put maybe 4 meter high. Then another node which may be 5 meter, and then 6. Then another one which can be 10, 4, and then 10, 0. So you can see, kind of like a standard portal frame configuration. Let's add a few elements just to visualize it better. Then into 2 and 3. I just try keeping the default section. So I don't want to enter section properties. It's maybe a little bit of long process, but standard stuff like from the Frame3D, same way you can consider tension only or compression only elements if you want. Then N3 to N4, then N4 to N5. So yeah, we got like a portal frame. This looks quite 2D. Okay, let me also add a few more nodes to make it 3D. Now I have paged the elements, so if you have more nodes, it do a paging. So we need now 10 nodes. So let me do 9, 10. Then offset it maybe by 4 meter this direction, so it's here. Then let me put everything in 4 meter. 4. Then so it's 400. Then 4. Oh, not that. This one's 0. That is 4. So I got this one. Then 4, 5, 6. So I got the 9th point. Then the 10th point is at, is it at 10? 10 4. So I got that one. Oh. May I repeat any point? Whether and 10. Oh, okay, and 6. There is another node at, maybe not. This is N8. Oh, okay. N8. I need to N7. Okay, I didn't place the N8 properly. Just put it for 5, 6, then 4, 10, 4, then 4, 10, 0. So we're looking good. N8, I need to put it at 6. Okay. Yeah, sorry. This is a little complicated. Okay, let me put the other elements. So N6 to N7, then N7 to N8. So it goes to next page. So this really helps. So if you have lots of elements, it doesn't go out of control like in the other module. But at some point I will try to incorporate the same thing there. So okay, so we have this, maybe add few members connecting these nodes. So I want to put one from N2 to N7, then N3 to N8, then N4 to N9, N4 to... Okay, so I don't want to add any diagonal members for the timing, just keep everything simple. So you can see how you entered. So now there is a new feature where you can see the node name. So if you toggle this, sorry, element name, see each element's name is displayed. So it is easy to recognize which element is which. There is also a property to show section name, what sections we assigned for each. So that really helps, like, if you have lots of different sections, you can kind of, so if we assign a user section here, you can see this one is user one. Okay, let me put it back. So section name is there. Then another new feature you can see is orientation of the local axis. So that really helps when you want to apply certain bending resistance in that direction, or the shear resistance, have more material in that direction if you want to get more shear. So these are some of the nice features where you can see element names, section names, and local axis orientation. There is a spring node similar to the 2D module. Then so this is where you enter the nodal load. So in the nodal load you can select, say let's apply 2 lateral loads here at N2 and N7. So N2, then you can pick different types of nodes actually. So there is an option to apply point load, moment, displacement, rotation. So let's apply a point load in the y direction, maybe a 5 kilonewton. So now we have applied a 5 kilonewton point load. Okay, let's apply another one. 7 F5, maybe a 8 kilonewton. 8 kilonewton load there. So we have 2 point loads. So there is other loads, so you can apply moment. See, you can apply a moment or a displacement. So this will okay, maybe I need okay, it's acting in, yeah, that's correct. It will pull it 8 millimeter and 8 meter in the positive direction, so you don't want that. Then there is option to apply rotation as well, so you can apply here rotation, then you need to apply in degrees. Yeah, okay, let's keep everything simple. Fy. Okay, now nodal restraints. So let's add some rigid restraints. Let's pin all the bases of the portal frame. So node 1, let's make it pinned. Node 2, make it pinned. Node 3, make it pinned. Oh, okay, maybe I was making nodes 5 actually, that's the base. Node 6, make it pinned. Node 10, make it pinned. So the supports are pinned. Now, okay, so maybe let's add some element loads, some UDLs coming from the roof. So we want to apply it along element E9, E10 and E11. Okay, let's apply along these three. So E9, let's apply the minus the direction F5 is 5 kilonewton. Then, yeah, E10. Set direction. Then maybe add -8. You can vary it, so you can put -4, and so it will be a varying load. Then E11, let's add -3 in this direction. Okay, so we got all the loads applied. Then there is another one called element release, where you can release the ends of the element. So for example, if you want this to allow it to hinge around these 2 points, you can do that. So you select the element, which was I think last element. Then say you want to allow it to rotate. So these are released with respect to local axis. So all are with respect to local axis. So maybe we need to see local axis. So let's see release y. True. Okay, this was the element is this direction, node 4 to node 9. So start true, then true, then this, it will be free to rotate, but just keep it off for the time being. This is how you apply it. I haven't tested it completely, so I don't want it to fail. So we have pretty much everything we need. Then maybe put a deflection scale of 10. See, we don't want to apply gravity because the default sections are huge sections. Probably this will fall down. Okay, let's hope it runs. Run the analysis, doing its magic. So analysis completed. So let's see the bending moment. So yeah, you see the bending moments. So you can see the bending moment, then the axial forces, shear force, then torque. Yeah, just some little bit of torque coming from these element load from the UDL, right, to kind of apply some torsion on these elements. Then the deflection, you can see we are kind of trying to push it sideways. Then there is UDL on these elements, so these are bending down, so kind of deformed shape. Then reactions at each supports, you can see here. Yeah, then there's you want to see the bending moment here, but it's kind of very crowded. So how do we view that? So there is option called, you can switch off elements by just switch on the legends. Then say for example you want to see the bending moment in this element at the end. So first we need to find out which element it is. See, when you hover over it, usually choose or why is it not showing? Let me see. Or best way is, I would say, we go here and we can just see the element name E11. So if we switch off E7, E8, E3, E4, E7, E8, 3, E4. So now we switched everything off. So now you can see, the end moment was -1, -2.55. So yeah, by switching on and off elements, you can kind of isolate the elements. They say double clicking will isolate element, but I don't know, it's not working. So once you're happy with the analysis, you can download it. So when you open it, you can see the report. You can attach it somewhere. I kept everything in white color, so you can easily attach. Then you can also see the data by clicking here. So, and you have all the controls you have in the app outside the app. So then you can switch off elements, show legend, everything is there. So yeah, so this is the Frame3D module. I haven't finished validating the app yet, but I will. And the site is getting very heavy, so I might move this to a different place in a different link. So maybe they just sent an email to standardsolver@gmail.com to get an early access. Probably there will be bugs, so you can play around with this and give me suggestions, or if you notice any errors, because I haven't tried all the load cases yet. Probably try to crowdsource it. Yeah, there is lots of other advanced softwares where you can do much more analysis, but what's the advantage of StandardSolver is, for you can just go to the site and quickly run analysis. You don't need to set up things. You just go there, create the model, and quickly check. So with StandardSolver, I've been trying to replace kind of hand calc rather than SAP 2000 or other advanced software. Like if you want to do like a small sense check, StandardSolver will be your helper. So that's kind of the aim. And I've been thinking about incorporating AI to pick, kind of automatically help the program to pick correct sections to carry the loads. But it is in a very, maybe only in my mind. So there is nothing started on it. And there's plate modules I want to do. So if you have like plate girders, or maybe retaining walls, brick walls, you can analyze them using plate modules. Even I haven't used in that much in my career, even though I have done lots of plate girders and stuff. But yeah, so yeah, please sign up and yeah, have a great day. So this is Frame3D coming soon. I don't know how soon, but a couple more weeks. So thank you. Thanks for watching.